All right, let's dive right in. Today, we're taking a journey into one of the biggest, most mind-bending questions in all of science. It's a question that starts in the super weird world of quantum physics and ends right inside your own head. So let's just get straight to it. Does your consciousness literally create reality? This isn't just some motivational slogan you see online. It's actually an idea that grew out of the genuinely baffling discoveries of early quantum mechanics. An idea that some of the smartest people of the 20th century actually took seriously. The real question is, does the science actually back it up? To figure that out, we have to go back to where it all started. We have to look at a puzzle in quantum physics that was so strange, it seemed to just completely break reality as we knew it. This is the mystery of the observer effect.
It all boils down to this one famous experiment, the double-slit experiment. The setup is pretty simple. You take a machine that fires electrons, one by one, at a wall with two little slits in it. Now, you'd think you'd just see two lines on the detector screen behind the wall, right? Kind of like you were firing tiny paintballs. But that's not what happens. Instead, you get this weird series of stripes, an interference pattern, exactly what you'd see if a wave had gone through both slits at the same time. And here's the craziest part. This happens even when you send them one at a time. Each individual electron acts like it somehow went through both slits at once. It's less like a tiny bullet and more like a wave of pure possibility.
So how in the world did the founders of quantum mechanics explain this? Well, they came up with something called the Copenhagen interpretation. And it basically says this. Before you look at it, an electron doesn't really have a specific location. It's not a particle. It's not even a physical wave in the water sense. It exists as this abstract cloud of probabilities called a wave function, which describes all the possible places the electron could be. Okay. So this is where it gets really wild. The theory goes that the moment you make a measurement, like when the electron smacks into that detector screen, that entire cloud of possibilities instantly collapses into one single concrete reality. Boom! The electron suddenly picks a spot. This moment of collapse is the bridge between the fuzzy, weird quantum world of maybe and the solid, definite world we live in. But that, of course, raises a massive question. Let's just follow the information. It's a path that physicists call the von Neumann chain. So first, the electron's wave function hits the detector screen. That interaction kicks off an electrical signal that zips through some wires to a computer. The computer then puts a dot on a monitor. Photons from that dot travel across the room, hit your retina, which sends another signal down your optic nerve into your brain. And then, finally, you become aware that the electron landed right there. So here it is, the heart of the whole mystery. Where in that entire chain did the collapse actually happen? When did that cloud of possibilities decide to become a single dot? I mean, think about it. The detector screen is made of atoms, which obey quantum rules. The wires, the computer, your eyeball, your brain, it's all just a huge, complicated collection of quantum particles. There is no obvious line where the quantum world ends and our normal world begins. This right here is the famous measurement problem.
Well, faced with this incredible puzzle, some truly brilliant physicists like John von Neumann and Eugene Wigner came up with a pretty radical idea. They looked at that whole chain and said, well, if everything in the chain is just another quantum system, what's the one thing that's different? What's the one thing that's unique? Their answer? The final step, conscious awareness. In their view, it's the mind of the observer that finally forces reality to pick a side.
Now this is the idea that just exploded out of the physics lab and into pop culture. It fueled all sorts of books and movies claiming you could literally will things into existence. But here's the thing, the science itself, well, it moved on. Even Wigner, one of the main proponents of this idea, eventually backed away from it. And why? Well, think about it. If you and I both look at the same experiment, we see the exact same result. The wave function collapses in the same way for both of us. And the only way that makes sense is if there's a single objective reality out there that exists, whether we're looking at it or not. So if consciousness isn't the magic ingredient, then what is? To find the real answer, we have to look at the next big revolution in physics, a theory that's even more precise and gives us a whole new way of thinking about what measurement and observation even are. Let's dig in. You see, before all this quantum weirdness, the world ran on the beautiful, predictable equations of classical electromagnetism. But as we started looking closer at the world, that beautiful picture started to crack. It predicted that hot objects should glow with infinite energy, which they don't. It couldn't explain why light's color, not its brightness, determined the energy of electrons it knocked off a metal. And maybe the biggest problem of all, it said that atoms shouldn't even exist. An orbiting electron should just radiate all its energy away and spiral into the nucleus in a split second. So yeah, classical physics was fundamentally broken.
The theory that fixed all this was quantum electrodynamics,
or QED for short, and it didn't just patch up the old rules. It threw them out and started over. In the old view, you had these smooth, continuous fields, and everything was perfectly predictable. But in QED, reality is made of these fundamental, choppy, quantized fields, and things are never certain, only probabilistic. But the biggest change, the one that matters most for our question, is how it explained forces. The old view talked about this spooky action at a distance. QED gives us something much, much cooler.
And this new way of looking at things gave us a totally new language to describe what's actually happening when things interact. A language that, as it turns out, solves the whole observer mystery.
So here's the absolute genius idea at the heart of QED. When two electrons push each other away, it's not because of some invisible, magical field. No, it's because they are literally playing a game of catch. One electron spits out a tiny particle, a virtual photon, and the other electron catches it. That exchange of momentum is the force. It's a physical interaction. Physicists actually draw this out using these cool little pictures called Feynman diagrams. They're like a comic strip for particle interactions. The lines on the outside are the real particles, coming in and going out. The points where the lines meet, the vertices, that's where the action happens, like an electron spitting out a photon. And that squiggly line in the middle, that's the virtual particle, the little messenger carrying the force between them. And that brings us all the way back to the beginning. With this new language of QED, what is a measurement? What is an observation? It's not some special act of consciousness. It's just an interaction. It's a particle exchange. When that electron from our experiment hits the detector screen, it starts exchanging virtual photons with the particles in the screen. That physical entanglement is the measurement. That's what collapses the wave function. A Geiger counter can be an observer. A rock can be an observer. Heck, a stray dust particle can be an observer. No mind required.
So case closed, right? The observer in physics is just any physical thing that interacts. But this solves one puzzle only to open up another, one that's much more personal. When we observe the world, when we pay attention to something, what is our brain actually doing? To answer that, we have to switch gears from physics to neuroscience.
A really brilliant neuroscientist named Amishi Jha has these two fantastic metaphors to help us understand our attention. First, she says, we have a flashlight. This is that tight focus beam you use to zero in on one specific thing, to see it in high definition. But we also have a floodlight. This is your broad, open awareness, just kind of taking everything in, not really prioritizing anything, just being aware of the whole scene.
Now, those are two of the three main systems of attention in our brain. The third one is what she calls the juggler. This is your executive control. You can think of it as the CEO of your mind. It's the part of you that sets your goals and then tells the flashlight where to point and tells the floodlight when to be on high alert. It's the boss.
And here's where this all gets really empowering. Because unlike a quantum measurement, which is this one-time irreversible collapse, our mental attention isn't a fixed thing at all. It's a skill. It's a mental muscle. And it's something we can actually train to make stronger.
So it turns out, the real challenge for us isn't some cosmic battle to create reality with our thoughts. It's the much more practical, everyday struggle of just paying attention to the reality that's right in front of us. The real enemy for all of us is mind-wandering. That moment our attention just gets hijacked and our flashlight starts pointing at random worries or distractions instead of where we want it to be.
So, here's a way to fight back. Think of this as a simple push-up for your brain, and it uses all three of those systems. Step 1, you anchor your flashlight by focusing really intently on a physical sensation, like your breath coming in and out. Step 2, you use your floodlight of open awareness to simply notice when your mind has wandered off, which it will. And step 3, you engage your juggler, your CEO, to make the decision to gently but firmly guide that flashlight right back to your breath. Focus, notice, redirect. That's the whole workout. And that really brings us full circle. The big takeaway here isn't that you have some secret power to bend the quantum universe to your will. It's that you have a very real, scientifically proven power to change your own experience of reality. By training your attention, you can literally change how your mind works. So the ultimate question isn't whether you're creating the universe, it's what you do with the time you have in it. Your attention is the most valuable tool you have for shaping your life. What you choose to focus on, moment by moment, truly does build your reality. So, where are you going to point your flashlight next?